So 6.2, the partial derivatives. First, I want to recall the formulas for derivatives. If y equals x to the m, y prime is mx to the m minus 1. If y equal the exponential function, y prime, we learned it as u prime times itself. If it's natural log of u, we learned y prime to be u prime over u. If it's log u base a, y prime is u prime over u natural log of a. If we have u to the m, y prime is m u to the m minus 1 times u prime by the chain rule. If y equals u times v, two functions, we use product rule. U prime times v plus u times v prime. Next, we have the quotient rule, u over v. Y prime is u prime v minus u v prime over v squared. Quotient rule. So in the previous section, we introduced more than one variable functions. So the function with more than one variable, let's say if two variables, we call it x comma y, means it's a function in the variables x, y, and you can call it z if you like. So let's take an example here, x squared y cubed plus xy plus 7y squared. Now, if we are asked to find or calculate f of x comma 2, how do you find that out? If you compare it to this, x stays x, but y is 2. So it's x squared times 2 cubed plus x times 2 plus 7 times 2 squared. This is 8x squared plus 2x plus 28. Up to this point, we are interested to find the derivative of z or f with respect to x. With respect to x means x is the variable. You'll get the big picture in a minute and you see how easy this becomes. So if I want to find the derivative for that, for what I just got, it's going to give me 16x plus 2. That's the derivative. Now what happens to the y? The y is gone. We replace the y with 2. So what happened to that 2? Well, it showed me that it's a constant that I selected. How about if it's not a constant? How would you find the derivative of that function with respect to x? The way things work out by assuming one variable is constant and differentiate. Either you assume x is constant or y constant. We differentiate with respect to the other variable. And this is called, in calculus, partial derivatives. You are differentiating only with respect to one variable, not two variables or three. So for example, if I want to find the partial derivative of f, we use this symbol like this. Partial f partial x. That's derivative of f with respect to x, or you can say z. Partial f partial x, or partial z partial x. Instead of writing down, use the simple like so. So for example, it will get easier in a minute. Find partial f with respect to x if f of x y is 2x cubed y. And then after we do that, we're going to find partial f with respect to y. So find this. Same thing, same function. So watch how we do this. Partial f with respect to x. Assume that 2, we know 2 is constant and y is going to be constant. So don't worry about the 2 and the y. They are constants. All you have to do, find the derivative of x cubed. And that would give us 2y. Derivative of this is 3x squared. So the answer is 6yx squared. Try the same way. Find partial f, partial y. For partial this means we're going to find the derivative of the same function, 2x cubed. So the x is a constant. All you have to do, find the derivative of y, which is simply 1. So that's 2x cubed. So you assume the rest are constants. Same, find partial f partial x if fxy equals x squared y squared minus 5x squared plus 3y minus 11. You can have 3 variables, and we'll ask you to find number 1, partial u with respect to x, partial u with respect to y, partial u with respect to z. Let's go over the first one, the partial f, partial x. Remember, the y's and numbers are constant. So what's the derivative of this? Is 2x, and just put y squared. Derivative of this is 10x. Derivative of this is 0 minus 0. So the answer is 2xy squared minus 10x. Partial u, partial x. So find the derivative of this with respect to x. Means any other variables, you look at them as numbers, as constants. So all you have to do, find the derivative of x squared, which is 2x, and keep the rest or the other variables the same. Try the next two the same way. For the next one, with respect to y, means you keep x squared the same. The y is 3y squared z to the 4th. So that gives 3x squared y squared z to the 4th. Next one, x squared y to the 3rd 4z cubed. 4x squared y cubed z cubed. Now they can ask us questions in a different way or format. So for, let's say, fxy equals 3x cubed y squared minus x over y. Find number 1, fx, like this, fxy subscript x. That means find the derivative of the function with respect to x, or partial derivative. That's the same as the partial f partial x. Again, this is the same as partial f partial x, just a different notation. Same thing we're going to find for y. To find the derivative with respect to x, 3x squared y squared minus, remember y is a constant, so this is the same as 1 over y x, like that. Keep the 1y the same, 1 over y. Derivative of x is 1. So the answer is 9x squared y squared minus 1 over y. Now the next one is more tricky. So to find the derivative of y squared, it's just 2y. But to find the derivative of x over y, you have to work it differently. So it's again derivative of this. So how do I find the derivative of this? 6x cubed y stays the same. You can take the x out, that's a constant. So we need to find the derivative of 1 over y. What's the easiest way to find this? This stays the same. Y to the negative 1 derivative. 6x to the third y minus x. Derivative of this one is negative 1, y to the negative 2. This stays the same. Negative negative is positive x. And bring that negative thing down to make it y squared. Okay, let's move on. A different example. Let gxy natural log of x squared plus xy to the fourth. Would like to find gx and gy. So partial derivative with respect to x, partial derivative with respect to y. Another example I'm gonna write now. E to the xy, y natural log of x. Again, find fx and fy. Fx and fy. So how do I find gx? Is the derivative of this with respect to x. Natural log of u, if you go back to the formulas we recalled at the beginning of the lesson, it says you find the derivative of this, which is 2x plus derivative of x is 1, y to the fourth, over itself. So gx is simply 2x plus y to the fourth over x squared plus xy to the fourth. Nothing can be simplified here. For the gy is the derivative of this, which is the derivative of x squared is 0. Keep the x the same, that's 4y cubed over x squared plus xy to the fourth. Gy equals 4xy cubed over x squared plus xy to the fourth. Fx, you find the derivative of this with respect to x. What's the derivative of the first one? If you remember, e to the u, it's the derivative of this times itself minus, remember we're doing with x, so y stays the same. The derivative of this is 1 over x. Let's see what we get here. The differentiation with respect to x, so the y is a constant. Derivative of x is 1 times this stays the same, We can rewrite this as y e to the xy minus, put the y on the top. That's f sub x. F sub y, same thing, we need to find the derivative of this with respect to y and derivative of this. Derivative of this is the derivative of the top, which is x times itself, because x is a constant. Derivative of y is 1 and keep natural log the same. So f sub y is xe to the xy minus natural log of x. That's all we have to do. I'm going to take a look at another function, but add more stuff to it. 4xy squared plus 3xy plus x cubed. If we try to find partial f with respect to x, what do we get? Derivative of x is 1, so it's 5y squared plus 3y plus 3x squared. That's the derivative of f with respect to x. Now, if I take that one I just found and try to find the derivative of this, so this means derivative with respect to y, what do we get? So means y is the variable now with respect to the y. So that gives me 10y plus 3 plus 0. What is that thing? Why we took the partial derivative with respect to y again? This can be rewritten as this. Has different notations. This can be rewritten as partial square f, partial y, partial x. It must be this way, not partial x, partial y. So when we do it, we do this one first. We find the derivative with respect to x, then this one. And you can rewrite it as fxy. If you write it in this format, fxy, you do this one first, then this second. So it's not the same if you do partial derivative with respect to x, and then y is not the same as y, then x. I'm going to write more examples. Now, what we need to find, what is fxy? Again, fxy says you find fx first. So we find fx, which is what? 8. Derivative of x squared is 2x. Y minus 3. Derivative of x is 1y plus 8. 16xy minus 3y plus 8. Now we found fx. Then to find fxy, it's basically you take the derivative of this with respect to y. So it's 16x minus derivative of 3y is 3 plus 0. So the answer is 16x minus 3. Again, this is the same as second partial of f, partial y, partial x. Get used to the notations. Find fyx. two examples. So for this one, fyx, remember you do this one first. So you find fy, the first one is 0 plus x cubed plus 0 minus 1. So it's simply x cubed minus 1. Now we take fyx, we find the derivative of this with respect to x, which is 3x squared. For the next one, remember we do this one first, then this one second. So we find the partial of f with respect to y first, which is keep the x squared out. The derivative of y squared is 2y. Keep the x out. The derivative of this is 3y squared plus 0. Then partial with respect to x now. What is that going to be? Is derivative of x cubed is 3x squared. Keep the y. Derivative of x is 1y squared. So that gives 6x squared y minus 3y squared. 3y squared. Now we're going to look at another example. 11e negative x squared y plus 8x. Let's try to find f sub x, f sub xx, f sub y, f sub yy. Then we're going to do f sub xy. So fx means the derivative of the function with respect to the variable x. This would be a negative 11e negative x, derivative of x squared 2x, and keep the y plus 8. Now, when we want to find fxx, what does that mean? It means you take fx and find the derivative again with respect to x. So what's the derivative of this? Is negative by negative positive minus 2y plus nothing. Fy means the derivative of f with respect to y. It's 0 minus x squared plus 0. Fyy, it's the derivative of fy with respect to y, which is 0. So fxy, we do x first, which we already did that. We just need to find it, which is this one. We need to find the derivative of that with respect to y. It's 0 minus 2x plus 0. So the answer is negative 2x. Now, what about if we look at a different one, fyx? What would that be? How do we calculate or find fxy or fyx? So this is, you start with this one first. Fy is negative x squared, right? If I differentiate that now with respect to x, that gives me also negative 2x. Any questions? To apply this to business calculus, how do we apply that? Mitel Cellular has the following production. Function for a smartphone. P of xy equals 50 x to the 2/3 y to 1/3, where P is the number of units produced with X units of labor and Y units of capital. Part A, find the number of units produced with 125 units. 125 units of labor and 64 units of capital. Then we're gonna find the marginal productivity. And lastly, we're going to evaluate the marginal productivity at X equals 125 and Y equals 64. So for part A, they want us to find the number of units produced with 125 units of labor and 64 units of capital. That means X is 125 and Y is 64. So all we have to do is go back to the function, given function Pxy, 50x to the 2/3, y to the 1/3, and find P of 125 comma 64. 50, 125 to the 2/3, 64 to 1/3. And you can put that in a calculator, and that gives us 5,000 units. 5,000 units. For the marginal productivity of labor, that's the same as finding the partial P with respect to X, or P sub X. Anything marginal means derivative, and because they're talking about productivity, that's why I use the P here. So I need to find the derivative of the function, this function here, with respect to X. So keep 50 the same. Derivative of X to the 2/3, bring 2/3 down, X subtract 1 from that, times Y to the 1/3. And what do we get here? 100 over 3, X to the negative 1/3, Y to the 1/3. But never leave negative exponents. So bring that negative exponent down, the X. So they said, find the marginal productivities. Remember, they said productivities, not just productivity. So the next one is I said P, partial P, partial Y. So we keep the 50, X to the 2/3 the same. Bring 1/3 down and subtract 1 from the exponent. Keep 50x to the 2/3 the same, 1/3, y to the negative 2/3 if you combine the fractions. Take the 3 out, so 50 over 3, x to the 2/3, and bring the y down, y to the 2/3. Part C, they want us to evaluate what we just got, P sub x at 125 comma 64. So if you go back to the answer we got earlier, the 100, and there was a 3 here, there was a y to 1/3 and x to 1/3. If you do it on the calculator, this will give you 4, this will give you 5. Simplify it out, you get about 26.66. Similarly, we do for P sub y at 125 comma 64. That's 50, 125 to the 2/3 over 3, 64 to the 2/3. Calculate that. I got 26.04.